Good morning again, Geometry Scholars. Here we are. We are starting a new unit. Now, our new unit is going to be on Chapter 8. We're going to be talking about similarity. We've been talking a lot about congruence. And then there's a slight bit less property that we're going to call similarity. Now, what we're going to do is take two sections from Chapter 4 on transformations, and we're going to put them into this chapter because they fit better. In Chapter 4, we talked about rigid transformations. Remember, we did translations, we did reflections, and we did rotations, where the shapes didn't change at all. But the fifth section was on dilations, where something can get from a regular size smaller or larger, just like your eye when you hit bright sunlight. So dilations is what we're going to do for the beginning of this section. As you can see, it's section 4.5. And so some of the vocabulary you may remember from Math 8. It is dilation, center of dilation, scale factor, enlargement or reductions. Enlargement, reduction. So in a perfect world, by the end of this video, you'll be able to identify and perform dilations and solve real-life problems involving scale factors and dilations. Let's go. So here's our core concept. A dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C, called the center of dilation. And a scale factor, we use the letter K, which is the ratio of the lengths of the corresponding sides of the image and the preimage. So what you do is you compare the sides, big to the small or the small to the big, depending on where the center is. So a dilation with center of dilation C and scale factor K maps every point P in a figure to a point P prime so that the following are true. If P is the center point C, then P equals P prime. That means there's no dilation if they're the same thing. If P is not the center point P, then the image P prime lies on CP, that ray. So from C going through P, you can see it there. The scale factor K is a positive number such that K is equal to CP prime divided by CP. So it would be from here to here, CP prime, that's the enlargement, divided by CP, that's the original. Angle measures are preserved. As you can see, all these angles are going to be the same. Now, to identify it, you do have to make sure you know which direction you're going. Are you starting with a small one and going big, enlarging? Or are you starting with a big one and going small, reducing? So a dilation doesn't change any line that passes through the center of dilation. A dilation maps a line that does not pass through the center of dilation to a parallel line. So in the figure that we're going to show you in just a second, PR is parallel to P prime R prime. PQ is parallel to PQ, P prime Q prime, and QR is parallel to Q prime R prime. So when the scale factor K is bigger than 1, that means that the dilation is an enlargement. It's getting larger than 100%. When K is less than 1, it's still positive, so it's between 0 and 1, then it's a reduction because it's going to get smaller than 100%. So here is an example where the dilations are being identified. So listen to when we talk about image and preimage.
Find the scale factor of the dilation. Then tell whether the dilation is a reduction or an enlargement. Solution. A dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation, and a scale factor K, part A, The scale factor is the ratio of the length of the corresponding sides of the image and the pre-image. The length of the image is CP prime, and the length of the pre-image is CP. So the scale factor is equal to CP prime divided by CP. So CP prime is equal to 12, and CP is equal to 8. Because CP prime divided by CP is equal to 12 divided by 8, or 12/8, the scale factor is K equals 3/2. When the scale factor K is greater than 1, a dilation is an enlargement. 3/2 is greater than 1, so the dilation is an enlargement. Part B. The ratio of the lengths of the corresponding sides of the image and the pre-image is CP prime to CP. In the diagram, CP prime is 18 and CP is 30. Because CP prime divided by CP is equal to 18 divided by 30, or 18/30, the scale factor is K equals 3/5. When 0 is less than K, which is less than 1, a dilation is a reduction. 3/5 is greater than 0 and less than 1, so the dilation is a reduction. The scale factor of a dilation can be written as a fraction, decimal, or percent.
So always remember, the pre-image is what you start with. The image is what you end up with. So you have to pay attention to whether it's a regular P or a P prime. Okay, here we go. We'll do these examples in class together with the class notes. Another core concept is how we can do this on a coordinate plane. Sometimes the easiest way is just to graph them. So you have a coordinate rule for dilations. If the point xy is the pre-image of a point, then its image after dilation centered at the origin, so C would be the origin 0, 0, with scale factor K, is the point P prime kx, ky, which means you're just going to multiply those numbers by the scale factor. So if your number is 1, 1, your first image, your pre-image, and your scale factor is 5, then P prime would be 5, 5, because you just multiply the two numbers. If you want to read a diagram for all the dilations in the coordinate plane, the center of dilation is the origin. So C is always 0, 0, unless it's otherwise noted, but we'll usually do it around 0, 0. So here's an example where we're dilating a figure in the coordinate plane.
Graph triangle ABC with vertices A, 2, 1, B, 4, 1, and C, 4, -1, and its image after a dilation with a scale factor of 2. Solution. Use the coordinate rule for a dilation with K equals 2 to find the coordinates of the vertices of the image. Then graph triangle ABC and its image. The coordinate rule for dilation states if point Pxy is the pre-image of a point, then its image after a dilation centered at the origin with scale factor K is the point P prime Kx, Ky. Because K equals 2, point xy maps to the point 2x, 2y. Point A, 2, 1 maps to the point A prime, 4, 2. Point B, 4, 1 maps to the point B prime, 8, 2. And point C, 4, -1 maps to the point C prime, 8, -2. Graph triangle ABC with vertices A, 2, 1, B, 4, 1, and C, 4, -1. Use line segments to connect the vertices to form triangle ABC. Next, graph triangle A prime, B prime, C prime with the vertices A prime, 4, 2, B prime, 8, 2, and C prime, 8, -2. Use line segments to connect the vertices to form triangle A prime, B prime, C prime. So triangle A prime, B prime, C prime is the image of triangle ABC after a dilation with a scale factor of 2. Notice the relationships between the lengths and slopes of the sides of the triangles. Each side length of triangle A prime, B prime, C prime is longer than its corresponding side by the scale factor. The corresponding sides are parallel because their slopes are the same.
So you should notice here, A prime, B prime is 4 units long, AB is 2 units long. So as long as you just apply this rule, you'll get exactly the same. You should notice also that the angles are the same measurement. Okay, here's another one, and this is slightly differently done.
Graph quadrilateral KLMN with vertices K, -3, 6, L, 0, 6, M, 3, 3, and N, -3, -3, and its image after a dilation with a scale factor of 1/3. Solution. Use the coordinate rule for a dilation with K equals 1/3 to find the coordinates of the vertices of the image. Then graph quadrilateral KLMN and its image. Because K equals 1/3, the point xy maps to the point 1/3 x, 1/3 y. So the point K, -3, 6 maps to the point K prime 1/3 times -3, which is -1, 1/3 times 6, which is 2. The point L, 0, 6 maps to the point L prime 0, 2. The point M, 3, 3 maps to the point M prime 1, 1. And the point N, -3, -3 maps to the point N prime -1, -1. Graph quadrilateral KLMN with vertices K, -3, 6, L, 0, 6, M, 3, 3, and N, -3, -3. Use line segments to connect the vertices to form quadrilateral KLMN. Next, graph quadrilateral K prime, L prime, M prime, N prime with vertices K prime, -1, 2, L prime, 0, 2, M prime, 1, 1, and N prime, -1, -1. Use line segments to connect the vertices to form quadrilateral K prime, L prime, M prime, N prime. So quadrilateral K prime, L prime, M prime, N prime is the image of quadrilateral KLMN after a dilation with a scale factor of 1/3.
That makes me laugh every time she says that, but see why you have to pay very close attention to what is the regular letters and what is the prime. So it's technically a dilation, but it's also a reduction, getting smaller. Okay. I don't think we're going to do every single part. This again will be examples during class notes, and we're not going to do constructions. We haven't been doing them this year because of COVID, but there is, notice that the different colors really help. So have your highlighters or your different colors, however that helps you. I always use highlighters and colored pencils. But one thing you can do to identify and perform dilations is that you can have scale factors that are negative numbers. And that's a little tricky, right? Because negative really will flip it. It'll make it a reflection. Anyway, let's read this. In the coordinate plane, you can have scale factors that are negative numbers. When this occurs, the figure rotates 180 degrees. So when k is greater than 0, so when your scale factor is positive, a dilation with a scale factor of -k is the same as a composition of a dilation with a scale factor of k, followed by a rotation of 180 about the center of dilation. Using the coordinate rules for a dilation and a rotation for 180, you can think of it like this. Your original point xy will map onto kx, ky, and then kx, ky will map onto -kx, -ky. So you'll still be able to just calculate the numbers, and this is what it looks like. Your scale factor, your pre-image is the small blue one. Your scale factor k is the gray one, and then the gray one will be rotated 180 degrees to give you a scale factor of -k. These where you finally end up with the red one. So here's an example.
Graph triangle FGH with vertices F, -4, -2, G, -2, 4, and H, -2, -2, and its image after a dilation with a scale factor of -1/2. Solution. Use the coordinate rule for a dilation with k equals -1/2 to find the coordinates of the vertices of the image. Then graph triangle FGH and its image. Recall, after a dilation with scale factor k, The point PXY maps to the point P prime KX KY. Because K is equal to negative 1/2, the point XY maps to the point negative 1/2 X negative 1/2 Y. So the point F negative 4 negative 2 maps to the point F prime 2 1. The point G negative 2 4 maps to the point G prime 1 negative 2. And the point H negative 2 negative 2 maps to the point H prime 1 1. Graph triangle FGH with vertices F negative 4 negative 2, G negative 2 4, and H negative 2 negative 2. Use line segments to connect the vertices to form triangle FGH. Next, graph triangle F prime G prime H prime with vertices F prime 2 1, G prime 1 negative 2, and H prime 1 1. Use line segments to connect the vertices to form triangle F prime G prime H prime. So triangle F prime G prime H prime is the image of triangle FGH after a dilation with a scale factor of negative 1/2.
You can see, again, the colors are very helpful, and we're almost done with this section. After this, we're going to do one more thing, and these are real-life problems. Again, problems in the class notes. So if you are, say you want to do photography, and you want to change the size of your picture, this is a perfect example.
You are making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the stickers is 1 1/10 inches by 1 1/10 inches. What is the scale factor of this dilation? Solution. The scale factor is the ratio of a side length of the sticker image to a side length of the original photo. A side length of the sticker image is 1 1/10 inches, and a side length of the original photo is 4 inches. So the ratio of a side length of the sticker image to a side length of the original photo is 1 1/10 inches to 4 inches, or 1 1/10 inches divided by 4 inches. To write in simplest form, you can multiply the numerator by 10 and the denominator by 10. So in simplest form, the scale factor is 11/40. Notice scale factors are written so that the units in the numerator and denominator divide out.
And that's it. You just divide what you start with where you want to go. Okay, here's another example. Finding the length of an image.
You are using a magnifying glass that shows the image of an object that is 6 times the object's actual size. Determine the length of the image of the spider seen through the magnifying glass. Solution. The image length divided by the actual length is equal to the scale factor K. You are determining the length of the image of the spider seen through the magnifying glass. So let X represent the image length. The actual length of the spider is 1 5/10 centimeters. So substitute 1 5/10 for the actual length. You are using a magnifying glass that shows the image of an object that is 6 times the object's actual size. So the scale factor K is 6, which gives you the equation X divided by 1 5/10 equals 6. Multiply each side of the equation by 1 5/10, and X is equal to 9. So the image length through the magnifying glass is 9 centimeters.
And again, very straightforward, but that helps give you an idea of real life examples. So at this point, we're going to be doing an assignment in Big Ideas. It's already popped up for you. You've got a couple days to do that, but get started on it right away. Any questions, go ahead and ask me during the class notes. And good luck with dilations.